ago, everything changed. The Virtual Telescope project just released images that shouldn't exist. Images that show an interstellar object defying the fundamental laws of physics. And I need you to understand, when I say defying physics, I'm not being dramatic, I'm being literal. On November 5th, 2025, two new photographs of the object designated 3I/Atlas were captured and released. What these images revealed has left even the most skeptical scientists at Harvard completely speechless. The photographs show Atlas as a compact source of light, just a point, nothing more, without any sign of a visible comet tail, no coma, no debris cloud, nothing. This should be impossible. Let me explain why. According to calculations by Harvard astrophysicist Avi Loeb, for this object to achieve the acceleration we're measuring, it should have lost at least 13% of its total mass by now. That's more than 5.5 billion tons of material. Imagine 50,000 aircraft carriers worth of ice and rock being blown off into space. That amount of material doesn't just disappear. It creates a massive, bright cloud that would be impossible to miss with our telescopes. But look at these images. Look at them carefully. There's nothing there. Just a point of light moving through space, accelerating in ways that gravity alone cannot explain, without showing any of the signs that physics demands must be present. To put this in perspective, the same virtual telescope images also captured Comet Lemon, a regular comet from our own solar system. Lemon displays exactly what we expect, a clear, bright tail pointing away from the sun, formed by solar radiation pressure pushing gases and dust into space. It's behaving exactly as every comet we've studied for the past century behaves. Atlas, on the other hand, remains mysteriously clean. No tail, no coma, no visual signature that should accompany the massive material loss necessary to explain its non-gravitational acceleration. According to Loeb, and I quote directly, "This is just the latest evidence that Atlas is not behaving like any natural object we know. And this leads us to a fundamental question that science needs to seriously address, a question that makes many of my colleagues deeply uncomfortable. But comfort isn't what drives scientific discovery. Evidence is. Let me be absolutely clear about what we're dealing with here. On October 29th, 2025, right at its closest point to the Sun, what we call perihelion, Atlas, began accelerating in ways that gravity alone cannot explain. NASA's Jet Propulsion Laboratory presented data showing that Atlas is now 4 arc-seconds away from where it should be based on purely gravitational calculations. 4 arc-seconds might not sound like much to you, but when you're tracking something 203 million kilometers from the sun, this deviation is enormous. It's like parking your car in London and finding it in Manchester the next morning. Something moved it, something we can't see. The object is accelerating at about 0.02 millimeters per second squared. Again, that might sound tiny, but over just 1 month, this small acceleration has pushed Atlas out of its expected path by about 80,000 kilometers. That's twice the circumference of Earth. The acceleration has 2 distinct components, and this is where it gets really interesting. It's pushing away from the sun at 135 kilometers per day squared. That results in about 60,000 kilometers of displacement per month, but it's also moving laterally at 60 kilometers per day squared, another 27,000 kilometers of lateral movement. This object isn't just drifting in one direction, it's being pushed outward and sideways simultaneously, as if it's following a deliberate trajectory correction. Now, before anyone panics, this acceleration isn't sending Atlas toward Earth. The deviation isn't enough to change its path toward any planet in our solar system except Jupiter, where it's expected to arrive in March 2026. So what exactly is non-gravitational acceleration? Think of it this way. When you throw a ball, gravity pulls it down in a predictable arc. We can calculate exactly where it will land. But imagine if that ball suddenly had small rockets firing on it mid-flight. It would veer off course in ways that simple gravity couldn't explain. That's exactly what's happening with Atlas. For a normal comet, we have a natural explanation: outgassing. When ice heats up near the sun, it turns directly into gas, a process called sublimation. This gas shoots out like tiny rocket engines, pushing the comet slightly off its gravitational path. We see this with every active comet in our solar system. It's completely normal, completely understood, completely predictable. The problem is the amount of gas that would need to be ejected from Atlas to create the acceleration we're measuring. Harvard astronomer Avi Loeb did the calculations using basic physics that any university student could verify. If you know the acceleration and you know the object's mass, you can calculate exactly how much gas needs to be ejected to create that push. It's simple conservation of momentum, the same principle that governs everything from rocket launches to billiard balls. Atlas weighs at least 33 billion tons. That's huge compared to the first two interstellar objects we've found. It's somewhere between 1,000 and 1 million times more massive than Oumuamua. It's about 1,000 times more massive than Borisov. Its core is estimated at about 3.5 miles or nearly 6 kilometers across. With that mass and the acceleration we're measuring, the calculations show something remarkable. To create that push through natural outgassing, Atlas would need to lose at least 1/6 of its total mass during the month around its closest approach to the Sun. That's at least 5.5 billion tons of gas that should be streaming off this object. Let me help you visualize what 5.5 billion tons of gas looks like in space. It would create a cloud so massive and bright that every amateur astronomer with a decent telescope could see it. Professional observatories would be capturing spectacular images of a coma, potentially millions of kilometers wide. The debris cloud would be the brightest feature of Atlas, outshining the nucleus itself by orders of magnitude. Between late November 2025 and late January 2026, dozens of ground-based telescopes will be watching. The Hubble Space Telescope will be watching. The James Webb Space Telescope will be watching. On December 19th, Atlas makes its closest approach to Earth at 167 million miles. If that massive gas cloud is there, we're going to see it. But what if it's not there? This is where the scientific discussion gets genuinely compelling. If we don't see that massive gas cloud, if there's no debris corresponding to the amount of mass loss required to explain the acceleration, then the natural explanation fails completely. We'd be forced to consider that the acceleration is coming from something else, something that doesn't involve massive material ejection, something potentially technological. And here's the thing that should make everyone pay attention. We've seen this exact pattern before. Oumuamua, the first interstellar object detected in 2017, showed non-gravitational acceleration but displayed no gas or dust coming off it. Even the super-sensitive Spitzer Space Telescope couldn't detect any outgassing. The scientific community ended up calling it a dark comet, which is essentially an oxymoron. It's like calling something a dry ocean. The defining characteristic of a comet is its tail of gas and dust. A comet without outgassing isn't a comet, it's something else. But Atlas is showing us something even stranger than Oumuamua. It's displaying additional behaviors that make the natural explanation even harder to accept. First, there's the brightness issue. As Atlas approached the Sun, its brightness increased following a power law with an exponent of -7.5. For those who don't speak mathematics, here's what this means. Normal comets get brighter as they approach the Sun, following a power law of -2 to -3. Atlas is brightening at more than double the rate we would expect. It's increasing in brightness much faster than any normal comet we've ever observed. This is completely unprecedented in cometary science. We've studied hundreds of comets over decades of observations. They all follow similar brightness curves as they approach the sun. Atlas is writing its own rules. Second, and this might be the most visually striking anomaly, Atlas is blue. Not just slightly blue, it's appearing bluer than the sun itself at its closest approach. This is extremely strange because dust naturally makes things appear redder, not bluer. It's why sunsets are red. The dust and atmosphere scatter blue light away, leaving the red wavelengths. Atlas's surface should be about 20 times colder than the sun's surface. Cold surfaces don't glow blue, they glow red. It's basic thermodynamics. The hotter something is, the bluer its light. The cooler it is, the redder. For Atlas to appear bluer than our sun, while being 20 times colder, is like finding ice that's hotter than fire. Natural explanations for this blue color all involve exotic processes. Perhaps ionized gases like carbon dioxide are emitting light directly through fluorescence. Perhaps there's some unknown interaction with the solar wind creating unusual emission spectra, but each explanation requires increasingly complex and unlikely scenarios. Now, it's crucial to understand what's really being argued here. Scientists aren't declaring that Atlas is definitely alien technology. That would be premature and unscientific. The argument is about methodology, about how science should respond when faced with mounting anomalies that don't fit our theories. Some scientists are saying the data must be wrong because they can't explain it. Dr. Avi Loeb's response to them was blunt. That's terrible science. You can't say the data is wrong just because you don't have a theory that fits it. And he's absolutely right. The history of science is littered with discoveries that initially seemed impossible. Continental drift was ridiculed for decades because scientists couldn't imagine how continents could move. The idea that rocks could fall from the sky, meteorites, was dismissed as peasant superstition until the evidence became overwhelming. Atlas represents something unprecedented in our solar system. Unlike anything we've ever observed, it presents not just one or two anomalies, but a whole collection of them. Let me walk through each one because when you see them all together, the picture that emerges is genuinely extraordinary. The first anomaly is the impossible path. Atlas is traveling within just 5 degrees of the ecliptic plane, the flat disk where all planets orbit our star. Imagine a cosmic pool table where all the balls roll on the same level. An object coming from another star system should arrive from any random direction in 3-dimensional space, from above, below, or any angle. But Atlas arrived almost perfectly aligned with our planetary table. The probability of this happening by chance is only 0.2%. That's 2 in 1,000. The second anomaly completely shattered our understanding of cometary behavior. During July and August 2025, Atlas did something never seen in nature. It created a jet of material directed straight toward our sun. This is the exact opposite of what should happen. All known comets create tails that point away from the sun, pushed by solar radiation pressure. It's as fundamental to cometary physics as gravity making things fall down. Atlas broke this rule as decisively as if water started flowing uphill. The third anomaly involves the impossible combination of size and speed. Atlas is 1,000,000 times more massive than Oumuamua and 1,000 times larger than Borisov. Yet it's moving faster than both. In nature, larger objects typically move slower. It's basic conservation of energy. Finding something this big moving this fast is like finding a cargo ship that outraces speedboats. The probability of this occurring naturally is less than 0.1%. The fourth anomaly might be the most statistically improbable. Atlas arrived with perfect timing to pass close to Mars, Venus, and Jupiter, while remaining completely invisible from Earth during perihelion, its most critical moment. The temporal precision of this sequence is extraordinary. It's like someone threading a needle while blindfolded, in the dark, during an earthquake. The probability, 0.005%, that's 5 in 100,000. The fifth anomaly emerged from spectroscopic analysis, and it's forcing us to reconsider everything we know about solar system chemistry. Atlas contains much more nickel than iron, a proportion typical of metallic alloys produced industrially on Earth. Natural comets should have random mixtures of metals, like a cosmic soup where ingredients are mixed by supernovae and stellar winds. But Atlas has a specific recipe, as if someone carefully chose the proportions. The probability of this specific composition occurring naturally is less than 1%. The sixth anomaly challenges the very definition of what a comet is. Comets are essentially dirty snowballs. They should be 80 to 90% water ice. Atlas has only 4% water. It's drier than many deserts on Earth. It's like finding an iceberg that's 96% rock. This characteristic is so unusual that if we discovered this object in our own solar system, we'd have to create an entirely new category for it. The seventh anomaly involves something called polarization, how light waves orient themselves when bouncing off surfaces. Atlas shows an extreme negative polarization pattern never seen in any other natural object, including all comets ever studied. Even Borisov, which we know is a natural interstellar comet, doesn't show this pattern. It's as if Atlas has optical properties that don't exist in nature's catalogue. The probability of this occurring naturally is less than 1%. The eighth anomaly sends chills down my spine. Atlas arrived from the same direction as the famous WOW signal of 1977, the most mysterious radio signal ever detected, and which many consider the best candidate for extraterrestrial communication. The directional precision is impressive, within just 9 degrees. In the vastness of interstellar space, that's like 2 letters posted from the same address, decades apart. The probability of this coincidence is 0.6%. The ninth anomaly is that impossible blue color I mentioned earlier. Atlas appearing bluer than our sun suggests it possesses an internal energy source or is undergoing processes that generate temperatures superior to our star's 5,800 Kelvin surface. It's like finding a candle that burns brighter than a bonfire. This indicates either exotic chemistry beyond our understanding or technology capable of generating extreme temperatures. And now we're waiting to confirm what could be the 10th anomaly. If the Virtual Telescope Project images are accurate, if there really is no debris cloud despite the measured acceleration, then we're looking at something that operates outside our understanding of physics. The physics is absolutely clear on this point. Massive acceleration requires massive mass loss through Newton's third law. For every action, there's an equal and opposite reaction. If gas isn't shooting out one way, the object can't accelerate the other way. It's not a suggestion or a tendency. It's a fundamental law that governs everything from rockets to recoiling rifles. If we don't see the gas cloud that physics demands must be there, we're left with only 2 possibilities. Either our understanding of physics is fundamentally wrong, which would be revolutionary in itself, or Atlas is accelerating through some mechanism we don't understand, perhaps something technological. As we approach December 19th, when Atlas reaches its closest point to Earth, hundreds of telescopes will be searching for those 5.5 billion tons of missing gas. Every major observatory on the planet is preparing. Software is being updated. Observation schedules are being coordinated. The entire global astronomical community is mobilizing for what could be the most important observation in human history. If that gas isn't there, if these new virtual telescope images are confirmed by other observatories, we'll know we're not looking at a comet. We'll be looking at something much more extraordinary. something that challenges our most fundamental assumptions about what's possible in the universe. The debate within the scientific community has become incredibly heated. There are essentially two camps forming, and the divide between them is growing wider with each new piece of data. On one side, you have scientists like myself and others who argue that Atlas must be a natural object, just an extremely unusual one. We point out that the universe is vast and ancient. Given billions of years and trillions of comets, even the most unlikely combinations of properties will occasionally occur. Yes, Atlas is strange, but nature is full of strange things we don't yet understand. On the other side, you have scientists like Avi Loeb who argue that when you have this many anomalies stacking up, when the cumulative probability becomes astronomically small, you have to at least consider non-natural explanations. They're not saying it's definitely artificial, but they're saying we can't rule it out based on the evidence. The frustration in the scientific community is palpable. We have an object displaying properties that challenge our understanding, but we're missing crucial data that could resolve the mystery. Some of that missing data is particularly infuriating because it exists, but we can't access it. There's the data from the JUICE probe, the Jupiter Icy Moons Explorer, which observed Atlas in detail during November. Those observations are sitting in the spacecraft's memory right now, containing answers to our biggest questions. But due to the vast distance and limited communication bandwidth, we won't receive that data until February 2026. It's like having a winning lottery ticket that you can't cash for 3 months. Even more frustrating is the situation with the Mars Reconnaissance Orbiter images. When Atlas passed within 30 million kilometers of Mars on October 2nd, the high-rise camera had the opportunity to capture the highest resolution images ever taken of this object. Those images exist. They're sitting on a NASA server somewhere. But due to the government shutdown that began October 1st, they haven't been released. Loeb has been vocal about his attempts to access these images. He's contacted the principal investigators directly. He's gone through official channels. He's even discussed it publicly in major media appearances. The response? Complete silence. NASA hasn't confirmed or denied the existence of these images. They've said nothing. This isn't a conspiracy. It's bureaucracy at its worst. At the very moment when we need all available data to understand possibly the most important discovery in human history, red tape and administrative failures are keeping crucial information locked away. But let's focus on what we do know, because even with missing pieces, the picture is remarkable. Atlas began its journey 7.5 billion years ago. Let that sink in. When this object started traveling through interstellar space, our sun didn't exist. The solar system hadn't formed. The Milky Way was a younger, more chaotic place with different spiral arm structures and stellar populations. During its billions of years of travel, Atlas has been exposed to conditions we can barely imagine. Cosmic ray bombardment that would sterilize any known form of life. Temperature variations from near absolute zero in the depths of interstellar space to potential close encounters with other stars. Impacts from microscopic dust grains traveling at significant fractions of light speed. The fact that it survived all this and still has volatile materials to release is remarkable. It suggests either extraordinary luck or some form of protection we don't understand. Perhaps a much thicker crust than typical comets, perhaps unusual structural integrity, perhaps something else entirely. The carbon dioxide dominance in Atlas's composition is rewriting our understanding of how comets can form. In our solar system, water ice dominates beyond the frost line. It's so consistent that we've built our entire model of planetary formation around it. But Atlas shows us that other solar systems can have fundamentally different chemistry. This has profound implications for our search for life in the universe. We've always looked for planets in the habitable zone, where liquid water can exist. But if other solar systems are built from different chemical blueprints, with carbon dioxide instead of water as the dominant volatile, then perhaps life could arise in ways we've never considered. Or perhaps life as we know it would be impossible, but other forms of complex chemistry could develop. The timing of Atlas's passage through our solar system raises interesting questions. We've only had the technology to detect interstellar objects for a few decades. The odds of 3 such objects passing through during this tiny window of human technological capability should be vanishingly small, unless interstellar space is far more crowded with wandering objects than we ever imagined. Current models, updated based on our detection of 3 interstellar objects, suggest there could be trillions of such objects passing through our galaxy at any given moment. Each one is a messenger from another star system, carrying information about conditions we'll never be able to observe directly. Atlas just happens to be the messenger we caught, but what a messenger it is. Every aspect of this object challenges our assumptions. The impossible acceleration without visible mass loss, the blue color that defies thermodynamics, the industrial-like metal ratios, the perfect orbital alignment, the anti-tail pointing at the sun. Each anomaly alone would be a major discovery. Together, they represent something unprecedented. As December 19th approaches, the anticipation in the scientific community is reaching fever pitch. This will be our best and possibly only chance to resolve the mystery. Atlas is on a hyperbolic trajectory. It will swing past the sun once and then leave our solar system forever, never to return. Every major telescope will be pointed at Atlas. Spectroscopes will analyze its composition in unprecedented detail. High-resolution cameras will search for any structural features. Radio telescopes will listen for any emissions. Infrared detectors will measure heat signatures. If there are answers to be found, December 19th is when we'll find them. The implications extend far beyond just this one object. If Atlas proves to be artificial, it would mean we're not alone in the universe. It would be the most profound discovery in human history, fundamentally changing our understanding of our place in the cosmos. But even if Atlas is natural, it's already revolutionary. It's showing us that the universe is far more varied and strange than we imagined. It's forcing us to reconsider our models of planetary formation, comet chemistry, and celestial mechanics. It's reminding us that we're still in the early days of understanding the cosmos. The Virtual Telescope Project images, released on November 5th, might be remembered as the moment everything changed. The moment we saw an object that shouldn't exist, doing things that shouldn't be possible, challenging everything we thought we knew. Science advances not through confirmation of what we expect, but through confrontation with what we don't understand. Atlas represents the ultimate confrontation, an object that defies our theories, challenges our assumptions, and forces us to think bigger. Whether Atlas is a natural wonder that expands our understanding of physics or something more exotic, it's already achieved something remarkable. It's united the global scientific community in a quest for answers. It's inspired a new generation to look up at the stars with wonder. It's reminded us that the universe still holds mysteries we haven't even imagined. As I speak these words, Atlas continues its journey through our solar system. Every second, it travels another 61 kilometers. Every hour, it's 220,000 kilometers farther along its path. Time is running out to solve this mystery. The countdown to December 19th has begun. On that day, we'll either confirm that we're looking at the strangest natural object ever discovered, or we'll face the possibility that we're observing something else entirely. Either outcome will be revolutionary. The universe has sent us a puzzle wrapped in ice and mystery, traveling for billions of years to reach us at exactly this moment in human history. The fact that we can detect it, study it, and perhaps understand it is a testament to human ingenuity and curiosity. But it's also a reminder of how much we still don't know. Every answer Atlas provides leads to new questions. Every observation reveals new impossibilities. This is science at its most exciting, not the recitation of established facts, but the discovery of new truths that challenge our most fundamental assumptions. In the coming weeks, as more data arrives, as December 19th approaches, as the mystery deepens or resolves, remember that you're witnessing history. This moment, this discovery, this cosmic visitor will be remembered and studied for generations to come. Atlas is more than just a comet or an anomaly. It's a messenger from the depths of space and time, carrying secrets we're only beginning to decode. Whether those secrets are written in the language of exotic natural phenomena or something else entirely, they're already changing how we see the universe. The images from November 5th show us something that shouldn't exist. The acceleration data tells us it's doing something that shouldn't be possible. The chemical composition reveals proportions that shouldn't occur in nature. Every aspect of Atlas is a challenge to our understanding. But that's exactly what makes it so valuable. It's forcing us to think bigger, to question our assumptions, to imagine possibilities we never considered. This is how science advances, not through comfortable confirmation of what we expect, but through uncomfortable confrontation with what we don't understand. Check out the suggested videos on your screen for more updates on this developing story. The universe is revealing its secrets